functions. So of course, based from our previous lessons in Math 3, the domain is just based on the idea of a vertical asymptote. So we know that an asymptote is a certain imaginary line that the graph will approach but will never cross it. So therefore, we can base the domain and range based on the asymptote. So let's go first on identifying what a vertical asymptote here. In our given function, y equals 2x minus 1 over x plus 2, okay, we cannot allow the denominator to be equal to 0. So to find the vertical asymptote is just putting it in the 0 form, the denominator itself, and so therefore x equals negative 2. Now this is the vertical asymptote. This graph will not touch this. So therefore, the domain are all values of x except for this. So your x now is not equal to negative 2. Okay? We can also write the domain, I'll write it here, as an interval notation of negative 2 to negative infinity. And I'm using parentheses because it doesn't include negative 2. It's not going to touch negative 2 in the graph, and negative 2 to positive infinity. Okay, so that's the domain. What about the range? And so we need to find the horizontal asymptote of our function. Now, how do we do the horizontal asymptote? So it's based on the degree of your variables, the highest degree of your variables. So what does this mean? If the degree of the numerator, so based from the degree is the highest exponent of your variable. In this case, it's x. If the degree of the numerator is greater than the degree of the denominator, I said it's none, but it's actually a slant asymptote. All right. But if for example this is 3 and this, you see it's 1 here, let's say I put 3 here and it's 1 here, 3 is greater than 1, so therefore you have a slant asymptote in the horizontal asymptote. Okay, so therefore there is no horizontal asymptote, it is a slant asymptote. Okay, meaning it's slant, it has a slope by itself. Now if the degree of the numerator is equal to the degree of the denominator, in this case both of them are 1, you just have to divide the numerical coefficients of the highest degree variable in the numerator and the denominator a over b. But if the degree of the numerator is less than the degree of the denominator, and then of course the horizontal asymptote is 0. Okay? Because these are asymptotes, the graph will not touch them. That's why to find the range, we just need the horizontal asymptote. So the horizontal asymptote, we have an equal degree here of the numerator and the denominator. So therefore, the range would be all values of y except positive 2. All right? Because you have your horizontal asymptote to be 2 over 1. There's 2 here and there's 1 here. So divide them, you'll have 2. But your graph will not cross y equals 2. So therefore, the range is y is not equal to 2 in the function itself. And therefore, the range can also be written as negative infinity 2 parentheses union 2 to positive infinity, except all of those values. Okay, so I hope it's clear. So let's try to find out the domain and range of the uh, inverse function. Okay, so it means that we will just have to flip. Now remember, the function itself has a domain of x is not equal to negative 2 and a range of y equals 2. Now let's see what happens if, based from principle, we can just flip. So therefore, the inverse will have a domain of x is not equal to uh, 2 and the range will be y is not equal to 2. So let's find out if that is true. So you have y equals 2x minus 1 over x plus 2. Alright, to find the inverse, we need to flip x and y. So you have x equals 2y minus 1 over y plus 2. Okay, and then of course, we need to cross multiply because we have fractional expression. So you have x times y plus 2 is equal to 2y minus 1. And of course, we need to let this out of the prison, okay? Because we need to put the y's together. So you have xy minus plus 2x is equal to 2y minus 1. And because we will have to put 2y together, 2y on the left side becomes negative and 2x becomes negative also. Alright, and then of course this can be factored with y, and you have x minus 2 equals negative 2x minus 1. Okay, so therefore we will divide x minus 2 over x minus 2. So that's cancelled. So y now, which is the inverse function of x, is equal to negative 2x minus 1 over x minus 2. Now, as you can see, the domain here, all right, based from our definition of a vertical asymptote, our x here, cannot be equivalent to 2. All right, based from the given function. This is our inverse function, and our range is that y here, you see, you have the same exponent for your numerator and denominator, so therefore it's is not equal to a over b, and our a is negative 2 over 1, which is equivalent to negative 2. So therefore, as you can see, this is the domain and range of our functions. Okay, based from our solutions before, the domain of the given function is x is not equal to negative 2, and the range is y is not equal to 2. Now, when we took the inverse function, it follows is that we just have to flip this. So x now is not equal to 2 for domain, and y is not equal to negative 2 from our range. And it really happens. So therefore, the conclusion, to find the domain and range of our inverse function, all you have to do is to flip the domain and range of our function itself.